Hey everyone, welcome to the final episode of Open Space for this season. The last day before I head off to the summer holidays. So we did it. We're live. This is, of course, not the end of all the cool space stuff that we do. This is just the beginning of our summer hiatus for the live shows. So just again, there's going to be tons and tons of additional space content coming out all summer long, but not the live shows. So no astronomy cast, no weekly space hangout, and no open space because I don't want to. It's hard to find internet, high-speed internet, all summer long, especially when we're out hiking in the forest, the beaches, going on various adventures over the summer. But lots of good stuff coming out all summer long, especially some of our live astronomy streaming with telescopes. So stay tuned. Lots of good stuff coming. But I'm happy to hang out for today and answer all the questions that you may have about space and or astronomy. So let's get into it. If anyone's got any questions, I'm happy to take them on. But I also want to give everyone a couple of reminders just as we move into this summertime. Two things that will keep you regularly connected to all things space. The first thing is, of course, our good friends at the Weekly Space Hangout crew. This is the community that was originally set up to handle the previous hiatuses that we've gone on to. So if you want to be a member of that community, go to wshcrew.space and they'll set you up. They'll give you access to their forum and various discussion groups, and even help you become an executive producer of the Weekly Space Hangout so that you can help organize the guests that we have both on the Weekly Space Hangout, but frankly here as well on Open Space. So whenever I have special guests, many of them are suggested by our good friends of the Weekly Space Hangout crew. So if you want to be a part of that, if there's someone you want me to talk to, join them, and then they will help you. They'll give you the instructions on how to bring on guests here. The other thing is, of course, my weekly email newsletter, which I will still be writing over the summer. There might be a couple of interruptions depending on how busy I get. But still, this is the newsletter that I write by email. Goes out to 17,000 of my closest friends. But I write every word inside of it. There's no ads, and it is just a full breakdown of all the big space news. Everything that I think is super interesting this week. All the stories, all the pictures, animations, videos, you name it. And some are links to Universe Today stories, and some are not. So definitely check that out. All right. Let's get on with some of the questions. So Dragonkin asks, when will we walk on Mars? 2038, I'm guessing. I don't know. Who knows? Right now, the current plans are the next human being to set foot on another place that isn't the Earth is going to be the Artemis Mission, which will be flying to the moon in 2024. That said, I don't think, the chances are like, 50-50 that this is going to happen. If there's any delays, if there's any problems with the Space Launch System, with the Orion capsule, with the Deep Space Gateway, with the lunar lander, with the budgeting, with the any of that, then we could see that date get pushed back. I think by 2028 is a more reasonable time frame for the moon landings to happen. So once that happens, then, of course, the moon is part of Mars, I believe, is the way this works. So that is just the first footstep onto Mars. But in order to actually be able to send humans to Mars, there is a lot that needs to come together. You need a spacecraft capable of making the journey, carrying human beings alive, protecting them from radiation for several months. That's not going to be super easy to do. You've got to have a way to get heavy payloads down to the surface of Mars. You've got to be able to set up factories capable of producing rocket fuel down on the surface of Mars to be able to send a return flight back home. So there's a lot. I think we're going to see, and so like a really fast time would be the end of the 2030s, I think. Now, that said, everything could be flipped around, right? You could see the SpaceX Starship which is going to be tested more. It's already been tested a little bit with the hops this year. They think that the orbital version of the Starship will be flying by next year, and you'll see the full stack of the Starship by 2020, 2021. And in theory, the Starship will be able to fly all the way to the moon on its own, land, return home, no fuss, no muss. And the Starship, of course, is going to be the vehicle that could theoretically go to Mars. Same thing. Launch, refuel multiple times from various refueling ships, and then make the flight to Mars, land through the atmosphere, and people can pop out on Mars, hang out, have a good time, and then go into some of the rockets that are building, that are building their rocket fuel on the surface of Mars and return home. So I think if we follow the normal trajectory with NASA and things like that, yeah, I think the late 2030s. If SpaceX pulls off something amazing, then maybe it'll be sooner. At the same time, the Falcon Heavy has taken longer to build than they were ever planning. The reality of building the Falcon Heavy was a lot more complicated than what they had planned. You think it's just bolting 3 Falcon rockets together, but it turned out to be a lot harder than they were expecting. Of course, as we are recording this, we are hours away from the launch of the Falcon Heavy that's going to be carrying a whole bunch of really interesting payloads. So, every day that goes by, SpaceX just keeps launching rockets, landing them again, and making things better. Grant Lanning says, when Starlink is up and fully functioning, providing amazing internet everywhere around the globe, will there still be a summer hiatus? I tell you what, if I can get a Starlink account and I can get a high-speed internet connection anywhere on Earth, I will not take a summer hiatus. I will keep doing shows over the summer. I may take a 1-month hiatus, but you got it. We can get Starlink. Because literally that's the thing, is that like I have a 600 megabit per second connection here at home. It can handle a very high speed upload. And all the times that we've tried to do shows on the road from hotels, conference rooms, things like that, it's so tough. So that's why we just try to instead just keep all my traveling for the summer. And so yeah, Starlink, you got it. If we get there, that'd be amazing. I can't wait. Bob, what if James Webb fails? James Webb won't fail. Can't happen. I refuse to imagine any scenario where James Webb fails. I'm not listening. So there we go. Moving on. James Webb will be successful. It will launch safely. There will be no problems. It'll make it out to its orbit, to the Lagrange point. It will unfurl its gigantic solar shade and its complicated telescope mechanism that's never been done in space before, like origami, and we'll be able to get to work. No problem. Oh. It's going to work. Warum KKKKKK. Why can't we detect Planet 9? It seems weird because we have cameras and satellites that can watch to the edge of the observable universe, but not just a few light days away. So the difference between what we can see with telescopes out to the edge of the observable universe is that those things are bright. When you look at a galaxy, you're looking at 100 to 400 billion stars, like our sun, that are blasting out radiation into space. It is the difference between looking at a light bulb far away, which you can see, and, I don't know, an apple in a dark room, only by reflected light. So looking for Planet 9, you're looking for just the faint reflection of light that is coming from the sun, and there's not very much light. Now, if the calculations by Mike Brown and Konstantin Batygin are correct, Planet 9 is out there, and theoretically it should be visible in the kinds of telescopes that astronomers are using today, the biggest telescopes. But the thing is that space is really, really big. There's a lot of just room to look. And the only way that you can do a search for a thing like Planet 9 is you've got to look at one teeny tiny little section of the sky, and then you've got to look at the next teeny tiny section of the sky, and then the next one, and you got to do this night after night after night to find anything that is moving through the sky at exactly the right speed for it to be Planet 9. And the only telescope that's going to be doing that in the near future is the Large Synoptic Survey Telescope, which is, as people who know, this is like the telescope I'm most excited about, because it is going to be doing exactly this. It has got this gigantic field of view, and it is going to look at the entire night sky every couple of days. And it's going to, at a level of depth, at a sort of a sensitivity that no other instruments have been doing up to this point. And it is going to find literally everything that's moving, all of the asteroids, all of the additional planets in the solar system. It's going to see supernovae. It's going to see just weird transient events that astronomers have never detected up until now, because they've never been able to watch the entire night sky night after night after night. And now they will. So I think this is going to be it's going to change everything. And like similar to like the Gaia instrument, right? The Gaia mission, which has been turning up just amazing discoveries because it is watching how everything is moving in the Milky Way. The LSST is going to change our understanding of vast parts of the universe because it's going to be seeing how everything changes over time. So that's when we'll know about Planet 9. And the LSST is coming fast. 2021, we should see first light. So we're just a couple of years away from, suddenly we're going to know of hundreds more Kuiper Belt objects, tens of thousands more asteroids. So stay tuned. Building with Todd. Hi, Fraser. Do you own a 3D printer? If so, what was your first print? And if not, what would you want to print first? So I bought my wife a 3D printer for her birthday. Such a romantic husband. And she did like a little print test cat that she downloaded. But it's still so finicky. And so she found the alignment was really tough, and it just wasn't worth her time to print little plastic goo gags. I think, what would I print? I would print Dungeons and Dragons figurines, because they're so expensive. And actually, because my kids and I were playing some D&D, and I found a bunch of models that people had done for building figures for D&D. So that's what I would probably print. 5 Aces 135. When do we launch the Fraser Cain telescope? Anytime. I think once the Starship is flying and space telescopes are cheaper and easier to launch, I would totally, maybe crowdfund with you folks. We'll build a space telescope. We're probably going to get access to a space telescope. Oceanside Photo and Telescope is in the process of launching a telescope. They're the people who lend me their powerful telescopes around the world to do the virtual star parties, and they're planning on launching a space telescope in the next couple of years, and they'll let us use it for the star parties. So stay tuned. That's probably the closest we're going to be able to get to. Cheesy McGeezy. Fraser, do you have any pets? Yeah, we have a dog. We have Ona, our deaf bull terrier, and she's actually with Carla right now on a fun road trip in the U.S. Raphael Dominichini. What do you think of the scientific programs trying to explain the Big Bang, showing a point in space that suddenly explodes? As far as I understand, this is an extremely wrong picture on the subject. Yeah, well, I mean, like, trying to critique popular science programs from explaining cosmology incorrectly. I mean, you could do that all day. So the thing is, like, the name Big Bang, yeah, we imagine an explosion. There's a black screen, and then suddenly there's this bright light, and then this sphere, this bubble expands in the screen with galaxies printed on the surface of it. And that's not correct, right? Our understanding of that picture of it is not what is happening in reality. And I use this analogy all the time, right? The best example is just imagine a grid. that just goes on forever in 3 dimensions, right? A 3-dimensional graph paper. And early on in the universe, that graph paper could have gone forever, infinite, and the cubes were close together. And here we are today, and the gaps between the graph paper are really far apart. But it still goes on forever. That is a much better understanding. And people will talk about ideas of like raisin bread or things like that, expanding. But that's the way to just describe it. Imagine graph paper where the cubes are really close together, and then later on, the cubes are really far apart from each other. That's the expansion of the universe. And some people are able to show that off correctly. But, it's a tough concept to wrap your head around. And the name Big Bang really doesn't help. Giannis Anti-to-go-to-MPO. Hello. Why couldn't we take a picture of the black hole of our own galaxy? We took a photo of a black hole really far away. So you're talking about the picture of the supermassive black hole that's at the heart of the galaxy M87, which was taken by the Event Horizon Telescope. And at the same time, the Event Horizon Telescope took a picture of the black hole SAG A star, which is essentially the supermassive black hole that's at the heart of the Milky Way. And the thing is that those 2 black holes are actually visually in the sky about the same size. But the one that's in the M87 is massive, while the one that's in our own galaxy is merely 4 million times the mass of the sun. So, the size difference is what makes them visually, even though the one in M87 is so much farther away. And from what I understand, I mean, the Event Horizon Telescope did take pictures of both black holes, but the problem is that the one in our galaxy, because we're closer, and it's much smaller. It's got a much more dynamic environment. It is spinning around, and things are changing in the order of minutes. And so it's really hard to take a picture of something that is moving that quickly compared to the one at M87, which may take weeks, rotating at almost the speed of light for these features to change. And so it's like a bigger technical challenge to capture pictures of the one that's in the Milky Way because it's changing so dynamically. That's what I understand is the main challenge. But I think we're going to see pictures of the one that's in our galaxy, I would say sometime this year, right? They've just got to do the crunching. They learned all their lessons with M87, and then they're going to do this one. And once they've done that, then I think that will really help them set the limits for what future objects they could go after. So we may, 10 years from now, have photographs of tons of supermassive black holes, and they can compare and contrast what they all look like. And then, of course, more and more telescopes will join the Event Horizon Telescope, and there will eventually be space telescopes joining the Event Horizon Telescope. So stay tuned. This is like on the same order of gravitational wave astronomy. You're just going to see new techniques unfold, more telescopes come online. It's just going to get better and better and better. Krishna Lockman, is it possible to land on the gas giants in the far, far future? Or is there no way that a manned base could be set up even a few thousand years of technology later? Yeah, you've got to understand what the environment is on the gas giants. The force, the first thing is that Jupiter, right? They're called gas giants. They are made mostly of hydrogen and helium. And in their upper atmosphere, they are like clouds. So you can't land on a cloud. But then as you go deeper and deeper down into the sort of towards the core of, say, Jupiter, then the pressures and the temperatures start to go up and up and up. And then you get deep enough into it, and like the hydrogen turns into a solid or turns into a liquid, but it's thousands of degrees. And as you get down into the core of Jupiter, it's like nearing, I forget the exact temperature, 25,000 degrees. Like, it's really hot. So hot that hydrogen is compressed into a metal that is rotating, and that's what's providing the powerful magnetosphere around Jupiter. So there's nothing in Jupiter that ever would feel like a planet that you would land on. It's not like a place that has clouds, and as you get down through the clouds and there's like a rocky spot that you could land on. It is like trying to land on the inside of a star. It's hard. So I can't imagine a future. I can imagine a future where spaceships will be able to like dip down into the upper cloud tops of Jupiter and scoop up hydrogen and carry that off into space for future fusion reactors. But apart from that, I can't imagine us ever trying to do anything serious with Jupiter. Is the sound in stereo or mono? Because I think I can fix that. Someone was saying that it might be in mono or in stereo, but you're getting it on your left ear. Let me see if I can fix that. Yeah, I don't know if that's going to change the audio level. Yeah, it makes it quieter, right? Let me fix this. Yeah, it should be mono. So if it's not mono, let me know. If you're getting only one ear as I'm doing this, tell me. William Simpson, do you think I will be able to go to the moon in my life? I'm 16. That's a good question. I think you can if you want to. I mean, the next people to set foot on the moon are going to be 2024. So that's 5 years from now. But then you're looking at decades of people setting up probably it's going to be like a long-term scientific outpost on the surface of the moon. But maybe you will be able to be a scientist working on it, and then eventually Starship will be going and carrying tourists to the surface of the moon, and maybe if you're willing to save up a few $100,000, you'll be able to do it. So if you set your whole goal to be able to walk on the moon, I think you'll be able to pull it off in your lifetime. Well, I guess people are saying that it's working. Yeah, so save your money. Evolution Inc. So am I excited for the Falcon Heavy launch tonight? Yeah, I'm excited by the Falcon Heavy. I'm totally going to watch this one. I got a bunch of reasons why this is a very special launch. The first thing is this is a launch that SpaceX is using to demonstrate to the Air Force that it can fulfill all of the weird orbits that the Air Force would like them to be able to do. And so this rocket has to do something very technically challenging. It has to launch, and then it has to essentially turn itself off and then turn itself back on, relight the engine multiple times to hit different trajectories to be able to launch spacecraft out into different orbits. So that is a technical challenge that SpaceX has never tried to demonstrate before. There's a collection of really interesting missions on this, and probably the one that I'm most excited about is the light sail that's being carried for the Planetary Society, Light Sail 2. Now, this isn't going to be a light sail that's going to go off to another farther into the solar system. It's going to orbit the Earth a few times, try to boost its orbit, but it'll probably crash in the coming months. But it will try to demonstrate whether you can actually use just light power alone as a method of propulsion for space, which is really exciting. And we've talked about this a long time. This is going to be one of the fundamental ideas for the Breakthrough Starshot program that will eventually take spacecraft to other stars. This is how it gets tested. So very exciting. And then the other thing is that we still haven't seen the central core of a Falcon Heavy come home safely. So the first Falcon Heavy, the two side boosters landed successfully, and the central booster crashed. With the last one, the two side boosters landed, the central booster landed, but the ocean was too rough, and so the central booster fell over and the top cracked off and fell into the ocean. So we still haven't had that perfect, successful Falcon Heavy launch, and that's what I'm hoping to see today. Something picture perfect. Chris M. Since time and space are relative, did time operate somewhat differently in the initial moments following the Big Bang, since the universe was so much smaller? Yes and no. So we've done a whole episode on this, but the gist of it is, and this is sort of fascinating, is that because of the expansion of space, things are moving relative to each other, right? That means that different regions of space have received different amounts of time dilation compared to each other. And that if you add up, your difference in time from, the maximum difference of time from someone else in the universe, it's about 30,000 years. So you have experienced, and in some cases, you've experienced more time or less time by about 30,000 years than other people in the universe, which is a mind-bending idea. So there is no such thing as time that is like absolute. All time is relative. It's a rounding error on the age of the universe as we understand it, but it's kind of a neat idea. Matt Gibson. Isn't the most probable great filter the probability of an intelligent species getting to a point where they can physically leave their planet before it's destroyed by their own star? So for people who don't know, the Great Filter is, of course, this explanation for why we don't see any aliens out there in the universe. The universe is big and old. There should be aliens everywhere. And so maybe there's something that stops aliens from being able to go to space. But so if you're saying they can't physically leave their planet, I'm not sure that's accurate, right? We're about to physically, like literally anything that we're going to be able to do, then aliens should be able to do that as well. So we're about to leave our planet. We're going to go back to the moon. We've already been to the moon. We've sent spacecraft to Mars. We've gone out of the Kuiper Belt. We've even sent spacecraft out of the solar system entirely. With the Voyagers and the Pioneers and New Horizons. They're gonna fly completely out of the solar system eventually after millions of years, tens of thousands of years. So we did it, right? So if we can do it, then you would imagine that other aliens, there's no reason in the laws of physics that would stop us from doing that. So you can knock that off as a possibility. Now, maybe you can't launch a big enough spacecraft or enough spacecraft or something that can survive the journey to another star. But we've seen space rocks make the journey from other star systems, right? Oumuamua was an asteroid or a comet that came from another star system. So if a rock can do it, we should be able to do it. David Wilson, how will the green propellant Infusion mission change the satellite game? So this is one of the missions that is going to be on board the Falcon Heavy when it launches. And this is a great idea. So up until this point, a lot of spacecraft use this material called hydrazine as a propellant. And it works great. It does the job, especially, in space, it works as a method of allowing spacecraft to make course corrections, be able to speed themselves up, slow themselves down. But the problem is that hydrazine is really toxic, especially to humans. Like if a spacecraft comes back to Earth and it's got hydrazine, it releases very toxic gases, very dangerous to work with. It's just very dangerous to make the hydrazine fuel, to fuel up the spacecraft and just be around it at any time. So one of these missions that's going to be on the spacecraft is this test of a non-toxic propellant that's going to be able to go to space. And if NASA can crack this, then they can reduce one of the risks that workers are put to as they're trying to build spacecraft, and that's exposure to hydrazine. So I hope this really works. Kua 1996. Are we able to tell the difference between a hot Jupiter and a brown dwarf very close to a companion star? Well, there's two ways that you can detect a star, a planet, right? The first way is that you can detect the amount of light that it blocks as it transits in front of its parent star. Now, the transiting method tells you the radius and it tells you the orbit, but it doesn't tell you the mass. And the weird thing about Jupiter-sized planets, in fact, if Jupiter was, the Jupiter in our own solar system, if it was more massive, then it would actually be a little bit smaller. So planets don't get a lot bigger than Jupiter. They just get a lot more massive, a lot more dense as they get more material on them. So side by side, a fairly massive brown dwarf and a less massive hot Jupiter would actually be pretty hard to distinguish. So the second way that you tell how massive a planet is or an object is using the radial velocity method. And this is where you detect the wobble back and forth of the parent star as the planets are going around it. And in that case, a brown dwarf causes a considerable amount of gravitational interaction with a parent star compared to something like a hot Jupiter. But the other thing is that brown dwarfs, they are called brown dwarfs because they are undergoing a kind of fusion in their cores called deuterium burning and tritium burning. And so they give off a very characteristic light in the infrared spectrum. So the way you really tell them apart is whether they're shining. But I guess what you're driving at is that because the planet is so close to its parent star, it is heated up and giving off a lot of sunlight or it is re-radiating the heat that it's absorbing, and it would be hard to tell them apart. And so you'd want to use the radial velocity method to tell them apart. Raza Siddiqui, a full transparent planet is possible or not, and if so, why, and if not, why not? What would you make a planet out of to make it transparent? That's the part that I don't understand. Like, what is something that's transparent, that's big? I can't think of anything, right? Hydrogen gas is transparent. And yet, if you mash enough hydrogen gas together, you get a star. And that's not transparent because it's like an ionized plasma. And that's not transparent. So I can't imagine a situation where you could have anything be transparent. Now, you could have blobs. There's these ideas of water worlds that are almost entirely made of water. And I guess if they were close enough to the star, but even water, right, isn't transparent. When you look at it, you're out in the open ocean and you look down into the water, you only see a little while before it gets too dark and you can't see through it anymore. So I can't imagine anything that would be transparent. Verstovsek. Hey, Fraser, can you explain a little bit about the axis of evil? Is Earth really in the center of the universe? How is this even possible? So there's two things. First, can the Earth be in the center of the universe? And so as we talked about earlier on, right, the universe, again, imagine it as this grid, this three-dimensional grid that goes on forever. And so there's no place in forever that's the center, right? Everywhere is the center. Nowhere is the center because forever in all directions is forever. So the axis of evil, what you're talking about is this image of the cosmic microwave background radiation that's been taken by satellites. And what that is, we're looking in all directions to the first light that we could see. And essentially just a few 100,000 years after the Big Bang, that is the first time that light was able to escape out into the universe. And the amazing thing about telescopes is that we're looking back in time as we look out in space. And so we're seeing this early light. And there's tiny variations of temperature that the most sensitive telescopes can see in this background radiation. And one of these areas seems to be outside of the normal temperature variations that you would expect to see. But it's entirely possible that is, it's just part of the error bars, part of the error of the measurement, and better observations are going to remove this idea of the axis of evil. So I wouldn't be super concerned about it. I've heard really dramatic ideas, like maybe it's a spot where another universe is bumping into our universe. But the most likely thing is that it's within the expected temperature ranges that astronomers would be expecting. It's just at the extreme. So nothing super weird, apart from seeing the earliest stages of the universe in all directions. That's pretty weird. Jim R. Do we have the technology today to extract water from the moon and turn it into rocket fuel? What would the size of the equipment be able to do that? You could build... So it's just electrolysis, right? So you just take water, you have a cathode and an anode, just two metals. You run a current through them, and bubbles of hydrogen and bubbles of oxygen will be coming off of the water. And the hydrogen and the oxygen that's your rocket fuel. So you could make a gadget for electrolyzing water very easily. So do it. Build now, to build a version of that can actually extract the water ice from the moon, can melt it down, can run the use solar panels to run the current through the water to be able to capture the gas and then turn that gas and store it in some kind of liquid form that could then be used by rockets. That's the challenging bit. The other cool idea that I've heard is that you just use steam. So you extract the water and then you use solar power to heat up the water, and then you spray that out at just like out of a nozzle, like a jet of steam, and you can use that as a propulsion system. So either way you want to go, whether you actually break it up and use it as, when you look at like the space shuttle, right? The main tank of the space shuttle is just hydrogen and oxygen. One big tank of hydrogen, one big tank of oxygen, mix them together, light it on fire, boom, you got rocket fuel. So that's why water is the core of everything that we want to find out in space. It's our rocket fuel, it's our atmosphere, it's our drinking water, it's everything. So if that's why these are the places that people are wanting to search on the moon and Mars and places like that, even Mercury, got to find that water. Arjone, how seat of your pants were the Apollo missions compared to what we would do today? What type of person should we send? I don't know if the Apollo missions were seat of your pants. I mean, I think that they tried to do the most careful missions that they could with the technology that they had at the time and the computers that they had at the time. But there was definitely a lot of parts where the astronauts were more manually involved in piloting the spacecraft, recovering from disasters in ways that maybe current astronauts probably won't do. I think things will be a lot more computerized for, right now with docking and things like that. So when the next group of astronauts go back to the moon, I'm sure a big chunk of it is going to be all computerized, and the astronauts will step in if they need to. But I mean, the pilots for the space shuttle, they were flying the space shuttle, which is one of the most complicated aircraft ever built. It was apparently like flying a brick. So I'm interested to see how it all plays out, how much computerization is going to be going into it. When you look at even in the Crew Dragon right now, it's just a few simple touch screens. So, as opposed to all of the knobs and dials that you see inside the space shuttle. Josh M., are you excited about China's space program? I'm excited about any space program, all of them, and definitely China included. They are making really steady progress to what is going to be their plan of landing humans on the moon. It's like there's no question that they're going to be doing this, right? It's going to probably take them still another, I don't know, by the end of the decade, but they're going to do it. And so as, say, the United States or Europe or anyone else is sort of going back and forth and changing goals and things like that, the Chinese are continuing on their process. They have, we're now at a point where they've already launched 2 space stations. They're working on their 3rd space station. They're exploring. They've sent 2 rovers to the surface of the moon. They've got a spacecraft that's orbiting that's at a point at the far side of the moon. And they launch a ton of rockets. I think they should really get into the reusable rocket game, because right now they just crash their first stage boosters into forests downrange of their rocket launches. But I think they're moving very quickly, and they're making a lot of progress. So we'll see what happens. Preston Thompson, if you had a blank check, what mission are you fully funding? I am fully funding a mission to Titan, a mission to Uranus or Neptune, or both, a lander, and I am writing a check for a space-based optical interferometer. So the biggest telescopes, or the most powerful telescope on Earth right now, is actually 4 separate telescopes. The Very Large Telescope down in Chile, and those 4 telescopes can work like one telescope using some really fancy technology, and that is called an interferometer. And so I want to see one of those from space, because then it would just be like a super duper version of the Hubble Space Telescope. The Event Horizon Telescope is another example of an interferometer, where telescopes around the world lined up their observations and were able to act like one telescope the size of planet Earth. Can you imagine if we got an interferometer, an optical interferometer like the Very Large Telescope, but out in space, so it could act like a telescope that is hundreds of meters across? That would be amazing. Ben Kalo, what would the sky look like from the edge of the Milky Way? All black or filled with naked eye galaxies? That's a great question. So if you were at the very edge of the Milky Way, you would still see stars in all directions, because it's kind of like no such thing as the very edge of the Milky Way. It's just like less and less density of stars. But you would definitely see the kind of the core band of the Milky Way in one direction, and you wouldn't see, so say during the summertime, as you look towards the core of the Milky Way, you would see the whole band of the Milky Way, and then it would peter off in both directions. And in the wintertime, you wouldn't see any Milky Way at all. And then summertime, the Milky Way would return, and then wintertime. But you wouldn't necessarily be able to see any more naked eye galaxies. I mean, it's not like you're going to be any closer to Andromeda, or like you'll be, say, 20,000 light years closer to Andromeda, but still, you wouldn't see a big difference. So in the perfectly dark skies, you would be able to see you see Andromeda, you could see M33, like the Triangulum Galaxy, you could see the Large and Small Magellanic Cloud, but that's about it. So it wouldn't really change your view of the night sky. You would definitely see less stars during, say, the wintertime, when the sun is in the core of the Milky Way. And then in the summertime, you would see tons of stars and the Milky Way. But if you lived in a city, then you just wouldn't see anything, right? Like you do right now. David Wilson, should I sell my Xenon futures and buy Krypton given Starlink's needs? Yeah, good question. I don't know how hard. Like Xenon is like, I forget. There was something that I saw that Xenon is the byproduct of some production, probably oil or coal or something like that. And not really sure where the Krypton comes from. I don't know if we're going to run out. Like we're running out of helium. Bob, what if we're alone in the universe? Then we're alone in the universe, right? If we're alone in the universe, then as, I forget who said it. Is it Carl Sagan? Someone said it. Then it's an awful waste of space, right? And it would be a tragedy that life came upon some planet and it developed into sentience so that it could perceive itself and perceive the universe, and then it proceeded to mess things up, and then the sun died, and then life was never in the universe again. Like, wouldn't that suck? Man. So my operating feeling is that until we find out that there are aliens out there and they've got things under control, right? Until we find out that in fact there's a vast galactic federation that is populated the Milky Way and is involved in trade and the universe is going to have life in it, we have to assume as if there is no life. And so we have to take responsibility for being the ones that make sure that life doesn't get wiped out of the universe. With our actions at this time, like we are literally at the moment in human history where we face a whole bunch of existential threats, some of our own making, some of which we have no control over, like asteroid strikes and things like that, that if we do this wrong, we could not be the life form that explores the cosmos. And it might be that maybe then the octopuses or the dolphins or the chimpanzees figure it out, or maybe we take them with us and then we have to wait for some future life form to do it, and maybe no life form ever figures it out. We've only got 500 million years left before the sun heats up to the point that large life forms on Earth are impossible. So time is running out. right? There's been life on Earth, big life forms on Earth for, say, 500 million years. We're halfway through that timeline, and we've got a crack at it. So that's my feeling. Now, I would love to believe that there are other aliens out there, and that they're doing the job, and we don't have to worry about it. But until we get proof, until we get evidence, the responsibility is on us, I think. So, Johnny Wednesday, if you could retrieve one piece of space hardware for historical preservation here on Earth, what would you choose? Oh, why do people only let me choose one thing? It's so mean. Because obviously the Hubble Space Telescope would be wonderful, but we've got versions of that. So I'd like to see a spacecraft that's seen some stuff. So like, I would love to see, say, one of the Venera spacecraft that landed on Venus, which went through the torturous heat and pressure to take the only pictures that we've got of Venus. I'd love to see that brought back to Earth so we can just see how badly it was melted and burned, and or say Opportunity, which is crawled around on Mars and wore down its wheels, and it's got probably pockmarks all across its solar panels. That would be amazing. So I would say if I had to pick one, it would probably be Opportunity. Dragon King, what is your answer to the Fermi paradox? My personal opinion, and there's a whole episode of space junk, and I put the episode into my podcast. So if you want to hear me talk about the Fermi paradox for like an hour, I highly recommend you subscribe to my podcast. Just search for Universe Today podcast, and you can find that. About 10 episodes back from now is where I uploaded an episode that I did on the Space Junk podcast, the second of 2 podcasts that I did with them, part of a trilogy. And I try to convince Dustin Gibson, the owner of Oceanside Photo and Telescope, that we are alone in the universe. And that's my opinion, is that the universe is big and old. Life should be everywhere. We don't see it. And the only thing that makes sense to me is that we are alone in the universe. But until we find evidence that we aren't alone, then we have to assume that we are, right? So, but yeah, if you want to hear me rant about it for like an hour and a half, that's your way. Let's see. Anders Ericsson, how is the state of cryonic suspension technology these days? Could we put astronauts into a suspended state over long space journeys? So I did a whole episode on hibernation, and the gist is there's kind of 2 lines of research into this. There's a short-term sort of suspension that they can do where they lower your body temperature and essentially put you into a coma. And it can last for a couple of weeks before it turns dangerous. And so the idea is that you would put the astronauts into this sleep while, say, the spacecraft is going to Mars for 3 months or 5 months. And so you minimize the amount of resources that they're going to require. You can maybe put them in a better shielded part of the spacecraft, because they don't need to move around. And so you minimize the resources, and it's sort of a very effective way. But that's about the limit to that. For longer term things, they would need to freeze you, like literally freeze you. And that, right now, you try to freeze a person and ice crystals form around their body and all their cells are exploded. But they are developing techniques to be able to freeze organic matter and be able, with some kind of antifreeze, and then be able to thaw it out later on. They can work on like chunks of meat, but who knows? In the next coming decades, they might figure out a way to be able to freeze a living creature so that they could restore it. And then you could go for almost any length of time. Pretty interesting ideas. I mean, it's a pretty scary thought, to have all of your bodily fluids replaced with antifreeze and then go to sleep. So, Alan H. Fraser, are all of the modules on the ISS open to all astronauts and cosmonauts, or do they stick to their own modules? What about their sleeping arrangements? Yeah, so there is a Russian side and there is an American side to the International Space Station. And to the large part, they stay to their own halves of the station. Although they visit with each other and they will perform science experiments together, in general, they have their own sides of the station, and that's where they sleep, and that's where they cook, and that's where they do some of their separate science experiments. And so it really is like a duplex when you think about it. It's a lot more broken up than you would expect if it was just one space station with a whole bunch of astronauts working together. But, I mean, they see each other every day. Right. It's just that in general, they stick to their sides of the station. But I mean, all of the U.S. astronauts are taught Russian. The Russians speak English, so you definitely are expected to be able to communicate with each other. Neil Yu, which probability is greater, that we're alone or that it's all a simulation? That's a good question. I mean, the problem is that the simulation argument, right, the one that's gotten Elon Musk in so much hot water, it's impossible to refute, but it's also impossible to find any evidence for it. So we may live in a simulation, but we can never know either way. So you have to live your life as if you don't live in a simulation. And then how do we know if we're alone in the universe? I don't know. We have to keep searching until we find out. William Simpson, how do I watch the podcast? Someone, I hope, can put a link into the YouTube chat. But if you just go to universetoday.com/audio, it'll take you to my podcast feed, and then the actual episode where I talk about the space junk goes back about maybe 10 episodes right now. It was about a month and a half ago. But I post like all the live shows that I do go into the podcast, and then also a lot of the interviews with me. So I ask for permission to put interviews with me into the podcast as well. All right. Evolution Inc. What do you think of a Venus rover? I've seen some images, and what I've seen look like tanks. It would be awesome to see more exploration on Venus. The problem with Venus, of course, is that it's hell. Right? It has, down at the surface, you're looking at 90 times the atmospheric pressure of Earth. The temperature is hot enough to melt lead. It is death for people and death for rovers. And so the Soviets were the only ones to be able to last any length of time on Venus. And the story of their landers is just amazing, because they sent a lander after lander after lander. And the way they died, each one, they got deeper down and died. It taught the Soviets the reality of what it was like down there on the surface of Venus. And it was only when they had finally built the toughest spacecraft they could possibly build that they were able to get down to the surface of Venus, and the spacecraft could survive for like an hour. And then they died. And so it was like they had they were like a thermos, like a reverse thermos, trying to keep the hot temperature out and the cold inside. And then they died. Now, the cool thing is that NASA has been working on some high temperature electronics. And so we might see a time in the next couple of decades where they can send a rover to Venus that could actually withstand the temperatures for long periods of time and actually rove around. And Venus is so fascinating because it is about the same size as Earth. It's made of kind of the same stuff as Earth. There's no more Earth-like place in the entire solar system than Venus in terms of mass and gravity and just the structure of what it's made out of. And yet Venus is a horrible, evil twin to the Earth. But you could answer so many questions if you could get down to the surface of Venus and crawl around and search for stuff. So please, a rover back to Venus would be great. Von Lichtenbutz, do you have any big plans for the 50th anniversary of Apollo 11? No. I mean, I'm really excited about the Apollo missions, and I've got like a pile of books have been sent my way from the publishers, and I've been sent a bunch of documentaries. So there's a lot of stuff. and there's going to be some really great live events. I think there was like a thing that I could do. I would love to go, like Morgan Renberg at the Fort Worth Museum of Science is doing a Apollo 11 exhibit this summer, and I would love to be able to go and check that out. So if you're anywhere in the area, you should go and check that out. But I'm sure like we're all just going to experience Apollo 11 mania this summer as we get closer to the anniversary. It's still just amazing that we are almost 50 years since human beings set foot on the moon. It's kind of sad and kind of exciting, but kind of sad. And hopefully we will go back. Let's see. We got 4 minutes left. Tommy Vass, Kate Fraser, what do you guess is the probability of a supernova visible from Earth for the naked eye within a lifetime or so? The probability of us seeing a supernova in our lifetimes is pretty good. I think that we are, in theory, they happen every few decades within the Milky Way. But the last one that was seen in modern times was the supernova that was in the Large Magellanic Cloud, supernova 1987A. And so here we are, 87, 97, 2007, 17, 30 years, 30 plus years away from the supernova that was visible to the unaided eye. But apart from that, we're due. And like Betelgeuse, can you imagine if Betelgeuse exploded? It would just be crazy. There would be this bright star visible in the daytime. That would be incredible. Tommy Vask, best tips for watching and or photographing the Perseids. So like this summer is going to be a bad summer for seeing the Perseids. The problem is that the Perseids are during almost full moon, which washes out a lot of the meteors that you'll be able to see. And the moon will be up all night long. So I would, this summer, if you wanted to go see the Perseids, I'd go a little early, like maybe go out 4 or 5 days earlier than the day that's supposed to be the peak. I forget the exact peak date. Is it the 11th? So go early. And you'll still see a bunch of meteors, and you'll have dark skies. That's the key. Meteor showers are made or broken based on the state of the moon. And assuming you can get away from light pollution. Get away from light pollution, find a great place, look up. But you can see meteors any night of the year if you just are patient and you just watch the sky. You'll see them. So I like meteor showers. I like the Perseids, but you can see meteors anytime you want. And then, of course, you could try to see if you can see Starlink, because the satellites are still kind of close together. So give that a shot as well. Let's see. Got 2 minutes. I caught the sun a bit, Fraser. Oh, yeah. Well, you'll see if you watch an episode, I get a little redder as I am concentrating and focusing. But yeah, no, I'm very tanned already, and it's only the beginning. We have been out in the sun doing tons of hikes so far from April. So we're going to do a lot of good stuff this summer. In fact, I'm about to fly down to Joshua Tree to join all of our friends for the All-Star Party, and then we're going to make our way through the California, the Sierra Nevadas, and do a bunch of hiking there as well. So I'm really looking forward to it. All right, Jay Alex Anderson, sorry about this, but we're going to wrap it up. So welcome and goodbye. So before I leave, I want to thank everybody for just all of your support over this year and all the previous years. It's been so much fun to interact with this community, and I really enjoy these live streams and all of the interactions that we get a chance to do. So much fun. And a huge thank you to the moderators and our good friends at the Weekly Space Hangout crew. They are just like so great to work with as a community. And we got some really exciting announcements that we're going to be able to make for next season. So you're all going to have to stay tuned as we figure all that out. Now, as I mentioned, we're going on hiatus with our live shows, but there's still going to be tons of other content, interesting surprises, my wacky experiments that I will be doing over the summer. So stay tuned as you'll see lots more videos. The next video that we're working on, we are doing is all about nuclear rockets, both fission and some new ideas for fusion rockets that seem actually pretty feasible. So that's coming out shortly. After that, we're going to be talking about a comet interceptor, something that might actually be able to meet up with the next Oumuamua. So that's in the works as well. More QA shows coming over the summer. So there's going to be lots of content. But I won't see you live until September. All right. Thanks, everybody. I will see you all in 2 months. Bye.